All right, old technology really works. Okay, so you know what good Python code looks like. You swear it's absolutely correct, but for some reason it's still a little buggy. All right, or maybe it doesn't perform as fast as you want it to. Okay, so this whole talk is about how do you improve your existing Python code to make it run faster? How do you not use up more memory than you should? And then comes the hardest part, which is understanding references well enough to know when it may cause bugs that you didn't even anticipate. Okay, so the nicer name of this talk is an ode to Python best practices in 9 parts. All right, so there's 9 little vignettes that I'm going to walk through, and you just nod your head and just take notes and move on. I'll get the slide deck available to Grace, and she'll post it to the conference website so you guys don't have to like jot notes down. All right, so background on me, I write. Some of you guys may have read into my book. That's great. If not, come see me. I've been a teacher for 33 years. My first paycheck as a teacher was in 1983. Anybody born on or after 1983? Oh, shit. Never mind. Just forget I said that. Anyway, I teach. I teach at schools, I teach at conferences, and I give talks at companies. Most important thing about me is that I'm a software engineer. I've done a lot with Python in my career. Probably the most well-known thing, I was one of the original 9 engineers that built Yahoo Mail about, I don't know, 1998. How long ago was that? I don't want to think about it. Anyway, so that's probably the most well-known thing that I've done in Python. The weirdest thing, or weirdest career I've ever had in Python was writing software for doctors to help them analyze patients for spinal fractures. So come see me. I know a lot about osteoporosis. All right? And it's not just the ladies. All right? 20% of everyone affected with osteoporosis are males. Okay? So you guys still have to drink milk and do weights. Those are probably the 2 best things. Okay, cool. This talk is not about me, it's about you. All right, so we're going to review objects and references. We're going to talk about good use of memory. We're going to be talking about being time conscious, that's performance-wise, and then mutability and memory referencing gotchas. All right, so hopefully you have some Python experience. You're not completely a beginner. But you still don't understand this behavior, like I said, where you swear your code is correct, but it doesn't work exactly right. And you want to learn more internals. Okay, so if this is you, then you're in the right place. All right, so the first one, we'll start off with the easy one. Minimize function and method calls. Try not to have as many of them, okay? So everybody knows what a stack looks like, right? So there's main down there and there's foo there. Okay, so I copied this from my C class that I used to teach, but you know, the concept is still the same, because if you're using C Python, then you know, it's one Python stack frame is one C stack frame. So what's a stack frame? Every time you make a function call, you have to push down all the parameters that go to the function, where it should return to, and what the local variables are. So this thing grows and shrinks. As you make function calls, the thing grows up. As those functions complete, those things get popped off. Okay? Every time you do a function call, it incurs some overhead from the operating system to have to actually put that together and make it happen, right? So believe it or not, it adds up over time. Okay? So for example, take a look at these 2 loops. Now this is really poor Python code, but I'll explain in a moment. But pretend you have a really, really long string. Which one of these 2, they both do the same thing, do you think is faster? First one or the second one? All right, who says the first one? Who says they both take the same amount of time? Who says the second one? Okay, see, you guys have good Python experience. All right, so you're correct. And the main reason is what? Okay, the length of the string is cached, right? So you don't have to calculate it every single time. All right, now under the covers, Python may do some optimization and know that, oh, the len function hasn't changed, and it may cache that. All right, but it's very interesting. I've had odd answers before from students. All right, I've had one student said, clearly the first one is faster because it's fewer lines of code. Okay, but that was back in the old days where lines of code mattered. Right here, it's all about optimization and not having to do extra work, right? Think of all the times you have to call that, right? And then another student gave this answer, which is, well, of course the second one is faster, because the first one has a red light, the second one has a green light. Okay, well, all right, sure. I was thinking about changing the colors after that class, but I decided to leave it. It's an interesting story. Okay, you passed the test. Part 2, is map and filter faster than list comprehensions? You know, a little skeptical about list comprehensions, or you know, you just want to know why should we use one over the other, all right? So map, as a review, if you don't know what it does, is it takes some function and then applies that function across every element of some sequence, all right? So back in the old days when range used to return a list, it still does in Python 2, but no longer in Python 3. But anyway, you can just pretend it's really that list there. It'll take this function and apply it to every single element of that list, okay? Everybody understand map? All right. And then filter is, let's take the same data set, okay? We have that list there. It'll return, it'll build a new list for, it'll take another function. It'll take an existing list or an iterable, and it will return you another one that only has it where this function returns true, right? So this is a function that returns whether or not it's an odd number, okay? So that's how filter works, right? So now we talk about our list comprehensions faster, okay? So let's take a look at these two. So you got map with ×2, so I'm just multiplying a number by 2, pretty easy, right? And they have the exact same thing in a list comprehension, right? Which one is faster? Can you tell by looking at this? What was the subject we were just talking about? Count the number of function calls, all right? So with this one, how many function calls are made to make this list happen? 7, right? ×2 is called 5 times, range is called once, and map is called once. 5 plus 1 plus 1 is 7, right? Let's look at the second one. How many function calls are made for this one? 6, okay? We got ×2 is called 5 times, and range is called once. So 6 versus 7 times, roughly performance is about the same, right? Okay, let's look at the second one with filter. So we have the odd one again. All right, so this time I have 10 numbers, and then I have odd, and I have filter. How many function calls for having filters output? 12? Everybody got 12? Okay, great. How about this list comprehension? 1, right? Just range. So 12 versus 1. Now, does that make a difference? Okay, yes, it starts to make a difference. What's the difference between these two? Why is this one so close and this one not? Right, if you look here, I actually called ×2 here, but down here, I didn't call odd. I just took the logic out of odd, like a lambda. I just took the logic out of it and dropped it in right here. So you could actually cut down the number of function calls up here if you just put I ×2 instead of ×2 of I, because we need to cut down on the function calls. They start to add up over time, right? So it's not that list comprehensions are faster than map or filter. It's how many function calls you make, right? So it depends, right? If you write your Python code this way, it'll be about the same. But instead of ×2 of I, if you did I ×2, it would be faster. Pretending, I mean, if your data set is large enough, right? And of course, instead of calling range, I would call X range in Python 2, because you want an iterator. There's no need to have all of that in memory, right? Okay, good. That was your second test. Part 3, what is wrong with lists? Okay, they're a really flexible, powerful data structure, right? They're mutable, they're resizable, they're awesome. And if you took a poll of Python users and you asked them what's their favorite language feature, they'll probably say it's list comprehensions. Lists are a great thing, right? Lists are horrible. Okay, they take up an unneeded amount of memory, all right? List comprehensions kind of get in the way a lot of times. And I'm talking about like real source code at companies that I've worked at where people are creating lists for no reason. You're creating a list with data in it. You're going through each element one at a time, and then you throw the whole thing away. You never really needed to have all of it in memory all at once. Okay? So the trend is to move away from lists in favor of iterators. So in Python 2, you have zip, you have range, map, filter, and dictionary dot, keys, values, items, all of those return lists. Guess what? In Python 3, none of them return lists. They're all iterators, right? In Python 2, if you want to get iterator versions of some of these things, you can. You can find them in various places. But the main idea is try not to do lists as much as you used to. Just kind of wean yourself off of it. You used to drink a lot, got to tone it down, maybe a glass of wine every now and then, okay? But just don't pound throughout the day, okay? This is a social, I'm trying to help you guys with life too, all right? So if you were looking for an alternative to list comprehensions, try generator expressions. The syntax is like nearly identical. It's just use parentheses instead of square brackets. That's it. Okay, it's as easy as that. What's wrong with this? We're running low on time, so there's the answers. Right? f.readlines makes a list of every single line in that file. What if it's a 4 gig Apache log file? That is so bad, okay? And you're creating a list. I'm probably just going to look at each line of the file one at a time. I don't need to have a list of all my files. I mean, basically, I'm making 2 lists of all the lines of my file. It's just the second one with strip means the new line's not on the end of the second one. I have 2 lists with my 4 gig Apache file. Okay, not so smart. And then down here, why do I need to do this silly nonsense? Okay, I'm not going to say what company I've seen this at, but there is code like this in the wild, okay? It's kind of scary. You may not code like this, but somebody else might, right? So don't waste memory. Change it so that you don't call read lines, all right? Use a generator expression. See, there's no square brackets, right? And there's no need to do X for X in, whatever. Just put them all together in one spot, and join will take care of that for you, all right? There's one more bug. Can anybody see it? Almost. Okay, I know with, that's coming up too, but there's one more bug with this code, okay? The problem is you close the file. A generated expression does lazy evaluation. It doesn't actually go into the file and grab lines until you start using it, which is down here. But the file has been closed already, so you're going to get an error, right? Okay, so yeah, it's closed. And what else can we do? Let's see. Okay, that's not necessary. You can actually just throw this line into here because join takes an iterable, and as you guys have said, use the with statement. So there's the last one. It's not too hard to read, right? I mean, it doesn't wrap. Well, I shrunk the font so it doesn't wrap. But it's not 80 characters, okay? So it's okay, all right? You guys getting the idea here? How you can iteratively improve what you have. Don't just go, get it working first, right? Because Python is the rapid prototyping thing. Get it working and then slowly tune it. I've gotten to the point where I'm actually refactoring as I'm writing the code. So it's a kind of interesting experience. Like, no, don't do that, right while I'm typing. So it's pretty amazing. All right, part 4. Know how the ref count changes. Everybody know what a ref count is? Who does not know what a ref count is? Okay, or not afraid to admit it. All right, so ref count basically is how many variables are attached to your object, how many variables are looking at it. In other words, this object will not be freed until nobody cares about it, which means the ref count goes to 0. Okay, so objects are allocated on assignment, and everything's passed by reference. Okay, don't get into the call by value, call by reference argument here. All right, because then I'll just take you outside. Okay, and then we'll finish that, and then we'll make a mess at the tables and stuff. Anyway, so references are also called aliases. The reference count is used to track the total number, but you have to count where does it increment, where does it decrement. Okay, and again, objects are only garbage collected when the ref count goes to 0. So reference. Okay, so if you guys are new to Python, all right, so this is only for the new people. Remember when for the rest of us, when we learned programming, it probably wasn't Python as our first language. We learned another language where variables are boxes, and you put values inside those boxes, right? Everybody remember that? You got taught that, right? The problem is that doesn't work in Python. You have to unlearn what you have learned. Okay? So it just doesn't work. It's inside out. Python is inside out. Variables are just like Post-it notes. Objects is where everything matters, right? So when you make an object, there it is, and the variable is just a Post-it note that's attached to it. And you can lift that Post-it note and drop it on something else at any given time. Okay? So you have to undo that thinking about variables, right? Additional aliases to an object can be created like this, x equals 1, y equals x. You don't have to allocate another object 1, right? I mean, there's another reason why you don't have to do that, but we'll get to that later. All right, so objects are garbage collected when the ref count goes to 0, but While ref counting is an easy way to understand memory management, you can have cycles. So Python has a cycle detector to look for that. That's where you have some objects referring to other objects, referring to other objects. And then if all outside references to those objects go away, but these internal objects still have references to each other, that ref count will never go to 0, and your memory will leak as a result of that. So that's why there's a cycle detector. Okay, so reference count is increased if you create an object and then you assign it. The very first assignment sets the ref count to 1. If you create additional aliases for an object, the ref count goes up again. If you pass that object to a function, a ref count gets incremented. If you stick it inside a container, it gets incremented. Okay? It goes down when, well, let's say you pass it to a function, that function ends, gets popped off the stack, right? We looked at that earlier, right? You can explicitly remove a name binding by using the del keyword, okay? Or you can assign that variable to some other object, lifting the post-it note off one object and stick it onto another. Or if it was in a container, you removed it from the container. Or if the container itself got deallocated because it was in a function that ended. Okay, so that's how reference count goes down, right? So that's a quick commercial break on ref counts. Now back to standard data types. So categorizing standard types so you can understand the relationships between them. Why do I do that? Well, to make you learn them faster if you're new to Python. If you already know Python, to make you understand them better, to kind of give you an idea of how you view them internally. And so what happens is when you're doing an application, you have a better idea as to which one should I use. Should I use a dictionary or a list? Should I use a list or a tuple? Things like that. These questions will be answered if you're very familiar with these. So the way I like to do it is I like to categorize all the standard types using 3 different models: storage model, access, and update model. So we'll go through each of the 3. Storage model is basically asking the question, is this a container or not a container, right? If it's a literal or a scalar, that's like all numbers and strings, they're not containers, right? But lists, tuples, dictionaries, and sets are containers. So this is how numbers and strings are more like each other, and lists, tuples, dictionaries, and sets are more like each other because they are containers. They hold multiple Python objects, okay? Strings would be if we had a character type, but we don't. So that's why they're literal, okay? Does everybody understand the storage model? Should be pretty basic. Okay. Another one is the update model. Can an object's value be updated? If it is a mutable object, yes, and if it's immutable, no. Okay. So what is mutable? Lists, dictionaries, and sets are mutable. That means you can modify them. All right. However, numbers, strings, tuples, and frozen sets are not. Okay. They are not mutable, meaning that you can't take a number and change its value. Okay, if you made an integer, 1024, you cannot actually change that value. You can, create another one, 1025, and assign the variable to that, but you can't actually physically change the integer object 1024 to have a different value. Okay, there's 2 different set types. There's a mutable set type and an immutable set type, and then byte array in Python 3 is a mutable object. Okay, everybody kind of understand the update model now? Okay. I mean, you can try it. Like if you have a list and you try and change an element in it, you do list, bracket, something, it works, right? But if you take a tuple and try to do that, it'll say, this object doesn't support assignment, right? So that's how you tell the difference between mutable and immutable. The last one is the access model. How do you access an object? Do you access it directly? Do you have to give it some kind of index if it was a sequence type? Or do you have to give it some kind of key if it was a mapping type? Okay, so numbers and sets are, you access them directly. Strings, lists, and tuples, you can access them with an index. And then for dictionaries, you use a key to get this value, right? Everybody understand that? Now, the interesting thing is when you take all 3 of these models and you merge them together, okay, you get an interesting interrelationship chart to see, oh, lists and tuples are nearly identical except one's mutable and the other is not. And numbers and strings are almost identical too, except one is direct access, the other one you need, to get into each character, you do need to have an index, right? And then, let's see, I think the other one is lists and dictionaries are similar because they're both mutable containers, but one's a sequence type needing an index and the other one needs a key, right? So understanding how they all relate to each other gives you a better idea, and you'll probably pick the best data structure for your use at the time. And there's also great data structures inside the collections module as well that Raymond, the keynote speaker, has put together, like ordered dict and dex, right? Those are also good data structures too. It all depends on, he's made those data structures geared towards performance. So if you do a lot of things with arrays like at the beginning and at the end, you probably want to use a deck. It's a little slower for things in the middle, but he's very performance-minded, which is great. Okay, so just keep these in mind. Collections module as well as the standard types. All right, cool. We're on to part 6 out of 9. Awesome. And your first quiz, which is, what is the outcode of the code below and why? Take a look at example 1. I have x is 42, y is x. I increment it by 1. Yes, I know I can do x plus equals 1, but you couldn't do that before Python 2.0 though. Okay. Print x, y. What gets output for example 1? 43 and 42. How about the second example? X is a list, 1, 2, 3. Y is x. X of 0 is 4. 4, 2, 3. Okay. So x is 42. Y is x. X plus equals 1. Okay. And then here's the other one. X is 1, 2, 3. Y is x. X of 0 is 4. And then what do we get? Okay. So you guys are correct. The thing is, it seems like these things should be similar. Why is it that the output is different here, but the same here? Okay, we go back to the M word, mutability. Numbers are immutable. Lists are mutable. Okay? Mutability leads to that. Okay, good job. Yep, look, I couldn't change the value of 42 to 43. I had to make a new object 43 and make x point to it. But x and y are pointing at the same list. The list is mutable, so if I change x, then I change y. Okay, everybody get that? Okay, cool. Part 7, interning. So, we all know what this does because we just covered it. What about this? If I do this, do I get this or do I get that? Top one or the bottom one? Gosh, you guys should be teaching this class. All right. Technically, you would think that you would get this one, right? But you don't because they're interned. All right, so some strings and integers are interned. The magic numbers are anywhere in this range of -5 up to 256. Okay, if you did it with 257 or floats, you actually get that. Okay, it's interesting. You can screw around with Python, like sit one afternoon and you can just like mess around with it for fun. Okay? All right. What is part 8? Ever seen this code? Ever wonder why it's not this code? Yeah? Anybody? Yeah? Okay. Hello? All right. It's really hard to see the pink circle. Okay? But what's happening is if you do, pretend you're a C programmer, okay? You're basically doing this comparison. Do I compare the pointers or do I dereference each one and then compare it later? Okay, is an object identity comparison versus equals equals, which is an object value comparison, right? If you just compare the pointers, it's a lot faster. So you can't see this, but on my Mac, in the Python 2, I get 0.05 seconds on average for 9 million loops of doing equals equals for none, okay? But using it's 0.03 seconds, all right? Running it 9 million times on average is about 0.031 seconds, all right? And then Python 3 numbers are down here. You can see Python 3 is faster than Python 2 now, okay, which is a good thing, okay? So the main idea is if you're comparing to true, none, or false, which are singletons, right, you should use is. But, you know, because we know that -5 to 256 are intern, don't do if x is 42. That just looks wrong. Okay, just pay the small price to keep your code readable. Okay? All right, the last bit, and then we'll wrap up. Copying objects and your last quiz. All right, so people, when they're new to Python, they often ask, so how do I copy a list? Because I need to take a copy of this list, I want to modify it and mess around with it, but I want to keep my original one. That's why you want to copy it, right? So there's 2 different ways of doing that. You can do list of your original list, or you can just take an improper slice, which is a slice of everything, which is no indices, I or J, with colon in between, All right, so x is that, y is that. I'm going to change y bracket 1 equals 4. Print x, print y. What's the output? What do you guys think is the output? Should it be the same or will it be different? Oh, very good. But that might not be intuitive at first, right? If you see this diagram, you go, wait a minute, if I'm going to change y bracket 1 bracket 0 equals 4, I'm only changing this one. X should still be 1, right? In your head, you're thinking that. Why is the output exactly the same? Okay, the reason is because I lied to you. Okay? When you're copying, you're actually not copying objects, you're copying references, meaning you're copying pointers. So x and y still point to the same string, the same list, the same number. Okay? So when I change y, I'm really changing what x is looking at too. Okay? It is not this picture. Oops. It is not this picture. This is the lie. All right? You didn't really copy this. Right? You copied the pointers, so keep that in mind. And by the way, if instead I changed y of 0 is bar, it would actually work. It would be different. Why? Yeah, the word m comes up again, right? Because lists are mutable, strings and numbers are not. If I change either of these other objects, it would be different output. It wouldn't be the same like this. If I changed y bracket 0 equals bar, this would actually say bar down here, but x would still say foo. Okay? So this is a bug that you may run into, but your code looked right. But in your head, you may be thinking this. Remember, a computer only does what you tell it to do, not what you want it to do. Right? That's the bad part. That's called debugging. That's okay. It's job security. Okay? So copying objects is trickier when it's mutable. All right? Just remember, making an alias is not a copy, because is works. Even if you make a quote-unquote copy, that's really called a shallow copy. While equals equals is the same, is not the same. So they are different objects. X and Y were different lists. It's just that they all had the same pointers inside them. Okay, if you really want to copy, you can use copy.deepcopy. But I'll tell you 2 pieces of advice with deep copy. One is that I've never used copy.deepcopy in 18 years of Python programming. Because what's happening is if I do want to modify, I want a modified copy of a list, I just basically create a list comprehension and I either map something to it or I filter out the stuff that I want. I never needed to make a full copy because I'm going to mess around with it anyway, right? And the second thing is deep copy only copies specific Python objects. You can't copy files, right? You can't copy weird data structures. You can't copy like instances. Okay, so it's only restricted to the most primitive data types. Okay, so you don't really always have to copy, right? Just take your original one and, work with that. Don't modify it, but extract the stuff you need out of it. Okay, all right. So that's pretty much it. So to review, function calls have overhead. Try to minimize that. Do you really need a list? Just think about that. That's a simple question to ask, right? Know how references and aliases work. All right, know the standard types better. Okay, and by the way, sets are awesome. So I didn't talk about sets that much, but they're awesome. If all you need to do is deduping, use a set, right? Frozen sets are really fast too, because they're immutable. Don't be afraid to diagram. All right, just like unfortunately, don't draw the wrong diagram like I did for you guys. All right, but diagram it out. It'll help you. And there's actually a website out there. Can't remember the name of it. Ping me. There's a website out there that will actually show you. You write some Python code, it'll actually draw the objects and draw little arrows and stuff and run the code one line at a time. It's pretty cool. It's written by one of my ex-coworkers. Yeah, I think so. I think something like that. You'll know it when you see it because you'll see the diagrams and the objects, so it's pretty awesome. Can you yell that out loud? Yeah, try that. Python tutor. Okay. Pythons are interesting out of the covers. What that really means is interning and is, not what your mind was thinking. Mutability is like the butler. They probably did it. Okay? Yeah, okay, pythontutor.com. All right, it's pretty awesome. Knowledge is power, so I'm telling you guys this because I want you to avoid writing an entire class of bugs. You can thank me later. Okay, believe it or not, those bugs will make you tear your hair out. I'm trying to give you some of the magician's secrets so that you don't even write those types of bugs. All right, and I have a whole bunch of more examples in the book. Okay, so that's it. Thank you very much.
Thanks, Wesley. And do we have any questions? We have about 10 minutes.
10 minutes?
Yeah, you went fast. That was great.
Oops.
What do you mean, oops? All right, back here, let me run the mic to you.
Hi, Wesley. Thanks. I'm just curious about the -5 to 257. Like, how did you come up with that? And is it probably is subject to change in the future, so we shouldn't rely on it, I assume?
It's binary.
Okay, so first thing is, I'm not on the core Python development team, so I didn't come up with those numbers. Okay, that's what they discovered over time is an optimal set of numbers that are highly used, and it's not documented, right? So if you look at the Python docs, it won't have any of those numbers, neither -5 nor 257, okay? Here's the best part. It can change, okay? So when I wrote the first edition of my book, I used Python source code to tell me what that range was. At that time, it was -1, 101. So basically -1 up to 100. When the second edition was about to get published, I said, oh, just for the heck of it, let's look for that 101 in the Python source code. The 101 was not there. So I was freaking out. I think my publisher is here. Where is she? Okay. She won't expose herself now. But anyway, I was like, where the heck is the 101? Because the book's going to go out wrong. So I did some digging, and I found they changed it to -5 to 257. So that doesn't mean it's not going to change in the future, but it's been stable for many years now. Okay? So that's my long-winded answer to your short question.
Other questions? Any answers? 42? Oh, sorry. Okay. Can you come to the center a little? Getting my exercise.
So this gives a lot of good practices. Do you really use if X is true in your code?
God, I hope not. Wouldn't you just write if X?
Yeah, that is true. So, get it? All right. Yes, that is better. Actually, if X is better than if X is true. So maybe none is probably the best one just to use. The funny story behind that, I always have funny stories behind people's questions, is that I totally didn't know any of this at my second job with Python. And let's see, is anybody here from... I was just looking for people that I used to work with. But I was like, I see all this code that was like, if X equals, if X is none, and X is true or whatever. I'm like, what the hell is this is thing? So I went in there and I changed them all to equals. And then I checked it in. And for some reason, the chief architect wanted a meeting with me. So I learned about is. In a less friendly environment than at a conference. So I changed them all back. So another funny story. You guys are asking the best questions. Anybody else?
Anybody up front?
Oh, there's one in back.
Of course. Come to the middle. Who was it? Come over
So about is, you'd use it with types also? Or that's for another talk, maybe.
Type checking.
Yeah, I have a completely separate slide just for that in my class. But for type checking, you wouldn't really use if x is str, because that really doesn't work unless x itself is the string factory function and the string object, which is probably not likely. So this is why, okay, I don't want to make the answer too long, but we used to have to do if type of x equals type of str or quote or something like that. So that was bad. Then we started importing types so that we could just compare it to the actual type object itself instead of calling type twice, because you got to minimize function calls, right? And then Guido's like, let's just forget this and just have is_instance. So is_instance got added in Python 2.2, and that's what you use to check types. So if is_instance paren x comma str.
But don't. Duck typing.
Yes.
So when would you actually use is_instance to do type checking versus relying on duck typing? This is like a whole different talk, but seems to be the question.
All right, it's trickier when it's duck typing.
Does everybody know what duck typing is? If it walks like a duck and it talks like a duck and you can use it like a duck, then it's close enough to a duck to use. So don't check your types. Don't check if it's a string. Just try and do string things with it. And most of the time, it will work. If it works for you, it's what you wanted.
Yeah, so that's the other thing is you should check if it's a file-like object, right? You can check to see, do has_adder, and check to see if it has a write method that you can call, right? Most file-like objects, as well as files, of course, have that, but maybe not all file-like objects will have a seek, right? So using has_adder will help you with that. So just check capabilities instead of types, because it may not work. I think is_instance, however, also works with base classes too. Yeah. So just any base class you could compare, but again, that may be too strong if you're not sure what type of your object is. Okay, good. That is another talk on its own, actually. Anybody else? Going once, going twice. See you at lunch. All right, thanks.
Thank you, Wesley.